Cable? Cable. Haha, there we go. every time. How's it going? Oh, you know what? I think I might be able to bring up the volume of the music a little bit on stream as well, because it's low-key kind of quiet compared to my voice. But hello everyone. It's nice to be back. It's coming into the Christmas season. It's getting nice and cozy. I'm ready to dive right in. We're going to start off on a new game today because, for those of you who didn't know, Tilelands, my current game, is out now on Steam. Came out 2 weeks ago on Wednesday, nearly 3 weeks ago now. And honestly, I'm so... Anyone who knows me, anybody who's watching has known me for like ages. Like Ellie, I see you in chat. Hello. But like releasing a game on Steam has been a dream I've had since I was like 12. So to be able to sit here and be like, it's finally happened, I finally released a game on Steam, is just like something else. It's literally a dream come true. So if you want to check it out, there is a link in the description. It's like £2.50, $3 if you're in the US, and whatever the equivalent currency exchange is depending on whatever country you're in. But it's a fun little tile placement game, kind of like Dorfromantik. Nope. Yes, Dorfromantik. We're going to be talking about the other romantic game, Dome Romantic, in a minute, but feel free to go and grab it. So what we're doing today, like I say, is starting on the next Steam game, and my friend Elle over here will know what this game is going to end up being, because she's one of the people who's wants it made. So basically, long story short, I have a group of friends from high school, the Big Six, we call ourselves, and I've wanted to make a game that we can all play for a while, because we try and like get together to play games on a Sunday evening every now and then, and now that Tilelands is done, I can actually spend some time working on this project, and it would be quite fun to look at doing something multiplayer properly now as well, with new updates to Unity's gaming services and all the rest of it. And also I've been learning Fishnet, so we could take a look at, you know, which one of those I'll dive into. But basically it's going to be like a Dome Romantic style or Dome Keeper style game for anybody who didn't know the original Ludum Dare version of Dome Keeper when it came out. And we'll go with this tower defense style structure where there's a central point that the player needs to defend, or the players need to defend, and then as the game progresses, harder waves of enemies are going to come along to try and clatter your tower, but you can build other towers to defend against this, and it'll be cool. There's some fun twists though. So twist number one, you don't have like towers in the traditional sense. Instead, you have components. So you build a tower base and a gun module or a control module or a walker module, and you can smash these components together to basically build little robots that will defend your base. And I think this will be so much fun to have in the context of like this kind of game, because it basically brings in some Factorio automation style elements where you can, you know, build up a little tower that will go out and harvest resources for you, build up a tower that will go around auto shooting robots, but also build up a tower that you can hop into and like drive around like a tank. I think that's so much fun as a concept. That is happy days for me. So that's twist number one. Twist number two is that you interact with the world as a player entity, so you're not like it's not like a top-down tower defense thing. You do have a physical controller, but that person that you control, that thing, doesn't have life and can't die. It can just become unconscious, and will become unconscious immediately when being inflicted. But there's also no concept of friendly fire, so if you were to like walk across the path of one of your friend's turrets that's shooting, they're shooting it, and it hits you instead of the enemy, you're going to become unconscious, and then one of your friends will have to come along and pick you up and run you somewhere else so that it can heal you. And yeah, it will just be like, if everyone goes unconscious, you lose the game, in the same way that if you like if your tower takes too much damage, then you've lost the game. So I think like conceptually it's probably quite a fun idea, and it will be like a really entertaining sort of Overcooked, Unrailed style survival escapade, which I think is pretty bang on the type of game that we enjoy in our friend group, and also a game that I think will be super fun. So without further ado, let's hop into Unity and start actually developing this. So the way that I want to do this, both as a series and development order, is to try and track as much of it in live streams as I can, and then we're gonna sort of go in it through iterations. So we'll start off by making the game as a local multiplayer or single player game, and then from that base, in a similar approach to how CodeMonkey did his multiplayer and single player tutorial courses, we'll take that single player base and upscale it to work in multiplayer, either using the Fishnet HL API or Unity's netcode for game objects. Haven't decided which yet, but we'll get to that when we get there. I want to focus on building out the systems in a good structure and a way that's going to be expandable moving forward, so that I can, you know, playtest this with the guys, with my girlfriend, with some other friends, and see how it all comes together. So this is a fresh project. All I've done is imported some like shaders basically, and like I've imported Odin Inspector as well, which is like an inspector enhancement plugin for Unity. We've got it set up using URP, and I've just rearranged things folders wise. I've also got the new input system going with an input control scheme, just for, because I know exactly what things I want the player to be able to do. I haven't actually bound any keys or anything to this yet, so we'll have to do that in a minute. And we're generating a C# class for that as well. And yes, the final other thing I've done is just import this standard method that I use for converting a vector relative to the direction that the camera transform is facing, so that I can make use of that, because I want this game to be like a top-down isometric type vibe. But outside of that, we have nothing. We're fully from scratch, sorry microphone, and we're going to try and build this out, like I say, using good code architecture, and really trying to adhere to some of the principles that I've been teaching recently as well, like solid principles, making use of design patterns, especially the state pattern, observer pattern, and probably some other more complex ones as well, but we'll see how we go when we get into it. Sure. Oh, I need to update the labels on the stream as well. Hey, GG Prods here. How's it going, man? Nice to see you. Hold on, I'm messing up all my scenes because I need to go in and change what the label's saying. What we are doing, we are making a new Steam game. Bang. There we go, update in real time. Sweet. So where do I want to start? I think I want to start by setting up some basic environments. So let's go ahead. But yeah, we're going to start off creating the player and explaining what I was saying earlier with how this is going to work. There should be complete separation between the handling of input for the player and the actual movement of the player controller, because we want to be able to have the player react with these tasks. So that's going to focus on. knock my cable out of place. I need to keep an eye on my thing down here. Yeah, if sound goes haywire, please somebody let me know, because I will not notice. Cool. I'm going to make a material or two. It's going to be my ground. And I'm going to make use of the FlatKit stylized surface, which I'm not going to have any shading, but I am going to make use of the Unity built-in shadows. And for anyone who hasn't seen this before, this is a asset called FlatKit by Dusty Room, I think they're called. Really cool asset for Unity, and I'm just going to make use of it for a second to kind of demo what we're working with here. I wanted to make a sphere, which again I'm going to reset to 0, 0 and then just bring up a little bit, and I'm going to create a directional light. Where is my lighting? There we go, directional light, and I'm going to have it pointing straight down. So 90 degrees on X, yeah, like that. And the reason for this is because now what I can do is go on to make sure this sphere has shadows turned on. Yep. And I want to make sure the directional light is casting hard shadows. Good stuff. And then on my ground plane, what we can do is actually specify like a custom color for the shadows that are going to come from our directional light. And we should be ending up getting shadows on here, but we're not for some reason. So I need to figure out why. Aha, there we go. It's because the color was white. Good to know. So, oh yeah, of course, because it's a multiply. It uses multiplication for actually drawing the shadows in. So I'm going to pick a shade of green, like a nice, maybe something like that. And let's go ahead and eyedrop that for our shadows as well. And actually, we could probably just use like black. Yeah. Yeah. Or maybe like slightly purplish. But like a decent color for what a shadow might look like. Yeah, something like that looks quite good. But then, yeah, so now we've got actual shadows going on here, which is quite nice. The only, obviously, we don't get like a change in depth, but we can now specify what things are going to cast shadows, and these shadows are going to like resize appropriately with the shapes, which is exactly what I want, and I want them to be going downwards. So this is all good. We now have a ground plane. Let's go ahead and make ourselves a player object, shall we? So I'm going to call this player pawn, like a pawn in chess, and we are going to reset this to 0. Hey, Corsair, how you going, man? We're doing good. Start up new Steam game, because like I say, the Tirelands, my current Steam game, is out now. Came out a couple of weeks ago, and if you haven't checked it out already, do go take a look. Very proud to have it done, and yeah, very exciting stuff. So this new game, we are today going to set up, I think, player movement and potentially some interaction stuff. We'll see how long it takes. My plan is to stream until 8, which means we've got just over an hour, so I might blitz through some things. We'll see how it goes. I'm going to create another material real quick for our player body, which I'm going to remove shadows from the player because I don't want shadows on the player, and I'm going to set the color to be like a shade of red, like I usually do for our player object. Oh yeah, sweet. Yeah. I'm a good follower of Sundown. I really love his content, and I've spoken to him a few times as well. Also, didn't realize it was his birthday recently, because it was my birthday a few weeks ago, so it's nice to be like, oh, sick, we share a birthday. That was quite fun. But yeah, I'm really glad that he's back. It's been really nice watching his content again, and seeing, like, yeah, the direction that everything's moving in for him. Let's go with that sort of a color for my player's body. And then I'm going to remove the capsule collider from here because this is just the graphics. Instead, we're going to add a character controller. Make sure that I move that up so that it's in line with our player. And immediately I'm already like loving just the feel of this. It's very Shepherd, which is exactly the kind of vibe that I want to go for. This game is a Dome Romantic or Dome Keeper style tower defense game that I'm making for primarily me and my friend group to play. But I will release it onto Steam as well because I actually think it's a really cool idea. The whole premise is that it's your standard kind of get resources tower based building defense game where there'll be waves of enemies every now and then and you build up weapons and upgrades for your central base to defeat them. But the twist being that those towers aren't like a set load of towers. You instead just have different modules that you build, like a gun module, like a legs module, a driving module, an auto AI module type thing, and then you plug them all together to build your own towers out of these components. And I think with some of the different like combinations that you can get with that, with the elements and stuff in the game as well, will make for some really fun emergent gameplay that I want to lean heavily into. So yeah, it's very exciting stuff. It's going to be my player eyes. And yeah, it's like, it's nice being able to make something for my friends as well, because I know especially like a lot of them have been so super supportive with me just making games in general, like, and I've been friends with them for, yeah, again, since I was like 12. So it's nice, one, that I still speak to them all and we still hang out and do stuff, but also just like being able to create a fun experience that's in a genre that we all enjoy. Yeah, it's just nice. It's just nice. I haven't in a while, actually, no, because he ended up getting a job in industry. To answer your question about if I've worked with Matt, yeah, he ended up getting a job in industry. I don't know how much I can share about it, but long and short of it is there was a strict non-competition and non-disclosure terms on the contract for that job. So yeah, since Thailand's, he had to leave that early, unfortunately, and we haven't been able to work on anything together since. But obviously I'm extremely glad for him. Like, it's really cool that he's managed to break into working in the AAA scene. So no bad blood or anything, just purely circumstantial. But yeah. Sweet. Yeah. It's almost a shame that it's such an industry standard, it feels, to have these non-disclosure agreements and strict non-competes, but hey-ho, what can you do? Right, I'm going to go in here and disable cast shadows on the eyes, because I just want the player to have this nice little disc underneath him. And I wanted to test something, actually. If I create a sphere like so, and have it cast shadows, but then go onto my materials and just remove all materials. No, it doesn't cast shadows anymore. Okay, that's good to know, because what I would ideally like to do is have, like, be able to create custom volumes for casting shadows but not have them render. And I suppose I can probably create a different layer for them and just have it not render, like not have the main camera not render that layer, but I think that will probably stop it from rendering the shadows for it too. So we'll see. Anyway, let's go ahead and get some player input going, shall we? So I'm going to create a new folder called player components under my scripts. And under here, I'm going to create a few scripts just straight off the bat that I know I'm going to need. We're going to have player input controller, which is going to handle our player input. I'm going to have a player... Oh, give it a minute. player pawn controller, which is going to be like our aggregate component for handling all of the delegation between input, movement, rotation, all the rest of it. And then I'm going to create some generic components. So we'll use a character, yeah, I'm going to call it CC for character controller, velocity controller, like that. And we'll also have a look at target controller, or look at direction controller, like so. And the reason I'm doing this is because I want to, like I said at the start of the stream, I want to try and stay true to good coding practices, solid principles, dry principles, and this heavily leans into the single responsibility that we don't want our player controller to be handling like everything for the player. We just want it to be like I say, an aggregate that's responsible for delegating behavior to the various subcomponents which can handle individual things like velocity, how the camera works, input, rotation, all the rest of it. And we can make use of all of our things like that. So before I continue with writing any code, let's actually set up what we want the controls to be. I'm going to add a up, down, left, right composite for the move, which is going to be WASD. And this is obviously going to be W, S for down, left will be A, and right will be D. Also, again, like I said before, if there's any issues with sound at any point, please let me know, because I have no point of reference for, yeah, for what's going on with my audio at the moment in my ears. Aim is going to be an axis. This is actually for rotating the camera. So I'm going to add a positive negative binding, which is going to be QE. Negative is going to be Q, because that's my left direction, and positive is going to be E. And again, I've named these generically because of the fact that I don't want the input to be specifically mapped to the actions of the player pawn. I want it to be mapped to whatever the player is controlling in a given instant. So, yeah, it can vary completely, depending on, you know, what context they're in. Interact, let's have interact be F. Or no, let's make it space. Let's make it space because we're not using mouse and keyboard. It's just going to be mouse for this. So, and then based on feedback from my friend group, we'll use J and K for our primary and secondary actions respectively. J and K. And then sprint can be left shift as standard, which I'm actually probably going to rename this to action. Oh yeah, we'll rename it primary modifier, which is gonna potentially get confusing down the line, but I'll see how I feel. Again, reason being, it's not necessarily going to cause sprinting. It's just going to be like a modifier for some given action. Like in the context of a mech or a tower that you've built, which can be controlled by the player, it might be that you hold down shift to use Q and E to rotate the aim direction rather than rotating the camera. Who knows? We'll see. We'll see. Cool. Let's start off by making this input controller then. So we're using the new input system, as I said before. We're using it with a C# class instance. So we're going to go ahead and just create ourselves a reference to that. We'll have a private controls, player controls. And maybe we have a public getter for that as well. Or maybe not. I don't think I necessarily need that for now. But we are going to have callbacks for all of the respective bits and pieces. So we're going to have a public vector2 move input, which is going to be equal to player controls dot move player, there we go, dot move, because that's our control scheme, dot read value as a vector2. Similarly, public float aim input. It's going to be our player controls dot player dot aim dot read value as a float. Float. There we go. And those are going to be all of our polling ones. Yeah, all the ones that we poll. The rest of them we're going to use events, because we don't need to be checking them every frame. We can just listen for when they're performed. So that is going to be a public Unity event on interact triggered equals new, and public Unity event on primary action triggered. One for our secondary. And one for sprinting, or the modifier, which I'm actually going to have pass through a bool. And this is going to be on modifier state changed equals new. Cool. So, I'm going to make a bunch of methods for those, because, or what? Yeah, I'm going to make a. I'm going to make a bunch of methods for those, because specifically with these, I want to be able to subscribe and unsubscribe the callback on enable and on disable. But then I also want to be able to, you know, not have it. Let's be able to read the value through and send it through, especially for the case of the modifier state change. So let's have a private void handle interact trigger. Going to take a callback context. Make sure we import that context. And actually, you know what? I think this can be CTX. And it's going to be a one-liner as well, actually. So for this one, we're just going to do on interact triggered dot invoke. Nice and easy. And this is going to be pretty much the same for all of the other ones. So handle primary action, handle secondary action, and handle modifier state change. So this is going to invoke on primary action triggered, on secondary action triggered, and on modifier state changed, and we're going to pass in context dot re. Oh wait, no. This one is going to be a little bit of extra steps. I do want to put this inside curly brackets, and then we'll say if context dot performed. So we pressed it. We'll invoke this with true. Else, if context dot cancelled, we'll invoke it with false. Sweet. And then we can go ahead and do a awake. We're going to say player controls equals new. And then on enable, we're going to say player controls dot enable. And we'll assign all of our callbacks. So player controls dot player dot interact dot performed plus equals handle interact triggered. And I'm going to copy paste this a whole bunch of times again. So we'll have primary, secondary, and then we're going to have two for our modifier, because we want this to be on performed and on cancelled. It's going to be handle modifier state change. Very nice. This is going to be primary action, and this is going to be secondary action. Handle primary action. Whoopsie daisy. And handle secondary action trigger. Oop, not hash set. Handle. God, handle secondary action trigger. Boom. Sweet. And then similarly on disable, let's go ahead and do the opposite of all of this, right? So play controls.disable, and we're going to unsubscribe from all of these events. Just to make sure we don't have any lingerers, because if you don't unsubscribe from your events and then you resubscribe again, you end up with things firing off twice, and we definitely don't want that. Sweet. So let's go ahead, and I'm not going to stick that on the player pawn because, again, if you remember, we want to keep these decoupled, and the player pawn doesn't like depend on an input per se. We're gonna have a way to depend on input, but we'll worry about that in a second. Let's go ahead and create our CC velocity controller. So I want this to require a component type of character controller, because it's a character controller, velocity controller. As such, we'll have a private character controller, which I will do in awake. We'll do a get component for that, because we know we're going to have it. And then we're going to have some things for our actual parameters. So we'll have a private float move speed, private float acceleration time, and then we'll have a bunch of stuff for handling our like what movement we're actually doing. So we'll have a private vector to target velocity, because this is another thing as well. We'll have it be a vector 3. Because it's top down, the player's only going to be moving in 2 axes. Like, we're not going to have a jump. I have no interest in putting jumping as a feature, but at the same time, like, there might be variations in terrain height, so I want to include some support for there being like gravity or sticking the player to the floor. So let's have a private vector 3 current velocity. We'll have a private vector 3 velocity smooth ref, because we're going to use smooth damp for doing our acceleration. I think that's probably going to be it, actually. I think that is probably going to be it. So let's create a public void set target velocity from input. Do I want to do that? Sure, let's do it like that. Vector to input. Nice and simple. Yes, I want a serialized field private float sprint speed. And then we can also have a private bool apply sprint modifier. So we'll actually have that be sprint modifier. Speed modifier. Yeah, keep it generic. Apply speed modifier. So then what we can do is also have a way of setting our speed modifier. Public void set apply speed modifier, takes in a bool, apply modifier, and that will simply say apply speed modifier equals apply modifier. Nice. So now we've got technically support for sprinting or applying some multiplier, some modifier to the movement speed. And yeah, we can go ahead and set our target velocity based on some input here. So we are going to say, let's say target velocity equals new input.x 0 input.y, and then target velocity times equals move speed, and then we can also say if apply modifier, we'll say target velocity times equals the speed modifier, and let's make sure that we normalize our input as well, because we don't want to be moving faster on diagonals. And for that I need to explicitly specify that it's a new vector 3. And then we can actually do some movement. So public void update current velocity equals vector 3 dot smooth damp. Current velocity target velocity, whoops, velocity smooth ref, and our acceleration time. Need to make sure that I pass that by reference. And let's also go ahead and say here target velocity dot y equals like -50, just to make sure that we've always got that negative, that downwards movement. Yeah, we'll do that for the time being. I'll explain why I'm hesitant to do it like that in a second, but I want to just get things moving first. So let's go ahead and say character controller.move, and we're going to pass in our current velocity multiplied by time.delta time. There we go. And I think that's actually everything we need. So we now have a generic character controller based movement controller. We can stick this on anything that uses a character controller, or that we want to use a character controller, and we have a interface by which to make it move. Very cool. So actually, yeah, let's go ahead and create our Nah, I'll do the look at direction controller as well. This is going to be pretty similar to our character controller. We are going to have a whoopsie daisy serialize field private float. No. Oh yeah. Private float, rotation speed. And yeah, we're using rotation speed instead of acceleration time, because we're gonna not use smooth damp. We're gonna use quaternion.slurp, spherical interpolation. And I think that's actually all we need, is the rotation speed. And then we're gonna have a private vector 3 target rotation. I think that's how we do it. Because what I want to do is basically... Oh, yeah. Target position. Look at position. And we can have a public void set look at position. Or maybe we call this lookout vector. Yeah. Because it's not necessarily a position. It could be, like, again, the input vector. Or the direction of movement for our player in this case. So we'll go ahead and say, yeah, lookout vector equals lookout vector. And then in our update, we want to say transform, wait, no, I want to get a quaternion new rotation equals quaternion.slurp, and we're going to go between transform.rotation target rotation equals oh wait, no, I do want this to be a vector 3, I think. I'm going to quaternion.slurp. Target rotation is going to be quaternion.lookat, I think. Look rotation. No. What am I doing? What am I doing? My gosh. Honestly, we want to get the direction from our position to the lookout vector. So we're going to say var look, or direction to target equals oh, we could use smooth damp actually and not bother with quaternions. I might do that. Direction to target equals transform dot position minus our lookout vector. We don't need a bracket in here. We can then say, let's have a private vector 3 target up, private vector 3 current up. Rename this to rotation time, and private vector 3 rotation smooth ref. We could say current up equals vector 3 dot smooth damp from target up, nope, current up to target up, with our reference for rotation smooth ref over rotation time. Do I use the $0.25 per engine install? Nope, because one, it doesn't work like that, but two, it's not on this Unity version. It's only introduced after Unity 2023 and onwards, and I'm on Unity 2022, so it doesn't apply to me. And then we will say transform.up equals current up. I think that should work. Only one way to find out, I guess. Oh dear. Let's go ahead and set some stuff up. So finally, our player pawn controller, and I'm going to add a summary comment to the top of this, because I want to put in line like what this actually does. Behaves as an aggregate for all components related to the controlling of a player pawn object. Takes some input and passes it to the respective components or relevant components. Cool. So let's go ahead and we're going to have a private CC velocity controller, which will be our velocity controller. We will have a private, and I'm going to make this a serialized field for the time being because I want to set it in the inspector. Whoop. Serialize field, private, player input controller, player input controller. We're also going to have a private look at direction controller, which will be our rotation controller. And I think that's everything that we've got for now, which is cool. We'll also have a private transform, camera transform, which we'll use to do our conversion between the normal input and the camera direction so that we're moving correctly there. How do I finish a game and make videos and live stream? Oh, this is so cool. I can't even make a game. It takes more than a month. Honestly, the answer is I can't. Anyone who's been following this channel for a while will know I started this channel literally 3 years ago. It was 3 years ago last week. And I started off making a game called Echo, which I'm actually going to switch to my face cam for this because I feel like there's a conversation we can have here about how the majority of people making devlogs or making videos on YouTube aren't actually game developers making devlogs for their game. They are YouTubers doing YouTube about game development, which seems counterintuitive, but it's more the approach that any of the content that a lot of people doing game dev videos nowadays make is like one-off little games, and the primary focus is the YouTube. They're making videos to get views, get subscribers, and all the rest of it. I don't want to be a YouTuber, but you know, I want to make games. I want to do exactly that, and making games takes time, usually more time than making consistent or like making regular videos in terms of like once a week allows for. And you know, that rings true with people like Thin Matrix or DevDuck, Sebastian Lake, other people like this who are developers, they're coders, they're game designers, and their focus is making games, but they don't release videos very often because they're spending their time making the games. And that's basically the boat that I'm sat in now, which is why there aren't any devlogs for the game Tirelands, which I just released. That game took probably about 8 months of part-time effort to develop. It's a very simple game from a code point of view and an actual like development point of view. But with that 8-month timeline of working on it part-time with, you know, someone else doing the art, someone else helping with the sound design, if I was making videos about that as well, it wouldn't be out by now, and I wanted it to be out in summer, so it's like way behind schedule. So to answer the question, how do I do it all? I don't. If I was making videos, the games would take way longer, like they did back in the day. The only reason live streams works out better is because I'm kind of a little bit eccentric, I think. I work a lot better when I'm talking out loud. So it's like one of those formats where having people like yourself watching and asking questions, it helps me to kind of figure out stuff in my head and iterate on ideas. And, you know, it's not the same as having to record a bunch of stuff, edit a video, write a script, and all the rest of it like you would have to do for normal YouTube. I can just, you know, stick the camera on, do the live stream, and I'm off and away just working on the game and interacting with people watching at the same time. So definitely, if it's something you want to do, I'd say do live streams and develop your game in those live streams, because you can still like be productive at the same time. But otherwise, it's more like you have to focus on being a YouTuber and making games second if you really want to find like good success at speed. Because again, people like Sebastian Lake, Thin Matrix, these guys have been doing it for more than 10 years and they have really good followings now. But that took, like I say, you know, 10 years for them to get to where they're at. And some people, you know, don't have 10 years of commitment to doing that. So yeah, completely depends what boat you're in, basically. Cool. Let's go ahead and set up some of these components. So I'm going to do a whole bunch of get components for our different things. I'm going to say velocity controller equals get component, velocity controller. Wait, come on. Rotation controller equals get component, rotation controller. Yeah, that's not what I called it. Look at direction controller. And camera transform equals camera dot main dot transform. Cool. So then the only question is just passing this, like passing through data from our input controller to these controllers. So we'll have a we will have a update method like so, and in this we are going to do a null check. So if our player input controller is equal to null, we'll just straight up return. And actually, you know what? Let's make a separate, good coding practice. Like I said, we're going to make a separate function. We're going to call it private void handle velocity and rotation. And we'll say if our input controller is not equal to null, then we'll do that. So velocity controller dot set target velocity from input, and we're going to pass in player input controller dot move input. Nice and simple, super easy now that we've got these separate pieces. And likewise, rotation controller dot set lookout vector, player input controller dot move input. Should be as simple as that. Ninja Man, you are very welcome. Hopefully it's decent advice, because that's what I aim to give. Oh, that's an important thing actually. We don't want to just pass through our move input. We want to pass in our move input relative to the camera. So let's do that. We'll say vector2 input relative to camera equals camera utilities. Make sure I import the namespace dot convert vector relative to camera, and we'll pass in our player input controller dot move input to there. And we also need to pass in our camera transform. And then we can use this vector in here instead. And that way, when we're moving around, the player is going to move relative to the direction that the camera's facing. Sick. Only last thing to do, and let's do this in start for the time being, but we're going to come back and refactor this in a moment. We'll say player input controller dot on modifier state changed dot add listener, and we're going to add in velocity controller dot set apply speed modifier, which takes a bool, this passes a bool, so all works out nicely. And you know, really we should be doing this in on enable, and then in on disable, we remove the listener. So let's do that, because again, good code practice. Let's keep good habits here. And now we can start building. We can build this thing out and we can see if everything is working nicely. So I'm going to go ahead and drag our pawn controller on here. We're going to drag in our CC velocity controller. I'm going to set the move speed to like 5, sprint modifier to 1.5. So that way we get move speed times 1.5, so it'll be 7.5 for sprinting. And acceleration time, let's make 0.125, so it's like there's a bit of acceleration but it's still responsive. Look at direction, rotation time, let's also do like 0.125, so it's relatively responsive. And then I'm going to create a separate empty object, which I'm going to call my player main controller for the time being. We'll come up with a better name in a bit. But this is going to be like what the player's actual stuff is on. This is where our player input controller is going to be. I probably want to hide all of these things in the inspector, but you know, we'll see if I decide that. Sign it the inspector there, and then everybody bless up. Give me thoughts and prayers. We'll hit play and see if this works. Cool. It does indeed be moving, and we can sprint. There we go. There's sprinting. It's moving relative to the camera. Let's just up this speed modifier to like 3 so that we can see that it is definitely sprinting when I press the shift key. There we go. But we're not rotating, and I need to figure out why that is, which is probably going to require me looking back at like some other code that I've got that's basically doing the same thing. Because I've got it somewhere in here from like when I've set up these kinds of systems before. Where's my update on this player controller? That's the input controller. I want the pawn controller. Set target velocity from inputs. Oh, maybe I was doing rotation from the velocity controller. In which case I probably would have been passing in nope, no, I wasn't. Maybe I was. Ah, yeah, here we go. Rotate to face movement direction. So yeah, if our current velocity is not equal to 0, target rotation equals look in the direction of the thing, and then, yeah. Cool. Alright, noted. So, what we can do instead then, let's still keep this separate. And we will, yeah, we'll pass in a vector 3 for our look at direction. And rather than doing this, we'll say if look at vector is not equal to vector 3.0, var target rotation equals quaternion dot rotate toward. Was it rotate towards? Look rotation. And we pass in our look at vector. And then we say transform dot rotation equals quaternion dot slurp. Transform dot rotation, target rotation, and it's going to be rotation speed now. I want this to be. Woo! Rotation speed times time dot delta time. Very cool. And then we can get rid of all of these references because we don't need them. So what we probably also want to be able to do is get our velocity. Although, if I'm passing in a vector 3 look at vector, yeah, I'm gonna want to make sure that I'm. Let's do this a bit more sensibly. Let's have a separate public void set look at vector from input, which is going to take a vector 2 input, and this is going to say set look at vector using new, and we'll do input dot x 0 input dot y. like that. And we'll normalize that as well. Cool. Cool. So now let's make sure to go in here and set our rotation speed to like 25. And I've forgotten to go back into my player pawn controller and make sure that we're calling set lookout vector from input instead of just the normal one. And now we should be there, ladies and gentlemen. We should be in the money. Yeah, look at that. We are going. Cool. And we can sprint. We've got a bit of acceleration. Moving with WASD. Fantastic. This is good stuff. Right, I've got about 20 minutes left. So, what do I want to do with that time? I think what do I want to do with that time? Let's finish setting up this player pawn controller as I want it. So, as I was saying before, the way that I want this game to work is that you're able to control different things, or it's not always going to be the case that the player is controlling the player pawn. They might be controlling like a ghost, or they might be controlling the turret. There's like a whole bunch of stuff that they could be doing. So we want to decouple any input requirement from the player pawn controller and just have it so that we can like set and unset this at runtime, basically. So let's get rid of this serialized field. And I'm instead going to have a private, public void set input controller. Takes in a player input controller, input controller, like so. And then we're going to move all of this callback into here, like that, the actual setting, the callback. Yep, that's cool. We'll also say player input controller dots. That player input controller equals input controller, and then we can set all of our callbacks. And actually, let's do some quick. I want to like put some protection on this. So let's have a private void clear all input callbacks, and this can do this. So we'll actually just call it from here, clear all input callbacks. And then we can also go on here and we can say if player input controller is not equal to null, we want to clear all input callbacks to make sure that we're not listening for events on the old input controller. Set the input controller to the new input controller, and then if player input controller is null, we're going to stop there. We're just going to clear it out. Otherwise, we set all of our input callbacks. And I guess I want to make sure that on enable as well, we're also apply. Let's do apply set all input callbacks. Set all input callbacks, like so. And we'll also only do that if player input controller is not equal to null. Private void set all input callbacks. make sure we call this down here. And let's actually do it like this, just so our, careful. Our code is laid out a bit more clean. Nice. So, because I blitzed through that super quick, and I like to use these as like some level of educational for people as well. Self-commenting. What we've done is basically make it so that this is not required on startup. And that the player doesn't, like, we don't need a player input controller for this to run without errors. And we've added in a method that can set the input controller. If we've already got one, we'll stop listening to any of the callbacks on it. We'll stop listening to any events from that old input controller. Set the input controller to the new input controller, and if that new input controller is not equal to null, we'll add our new callbacks onto that new input controller. Cool. So, with that out the way, we're going to create a new player controller. Yeah, I'll leave it as player controller, just straight up. And this is actually going to be the thing that we have our input on. So we'll serialize field, private player input controller. Player input controller. We'll also have a serialized field for a private player pawn controller, which is going to be our player pawn prefab. And we will say public void spawn player pawn. And we'll quite simply just do let's make sure we got a reference to that player pawn as well, actually. So private player pawn controller controlled pawn, and we can say controlled pawn equals instantiate player pawn controller player pawn prefab at vector 2.0, all normal. And then we'll just say controlled pawn dot set input controller to player input controller. Like so. And then in awake we can just call this method for the time being. We'll do it in start actually. Spawn player pawn. Remove our unused using statements. Cool. So now we've got this this player controller, which will make this require our player input controller, actually, because this does need one. We want it to have one, and that way we can make this not a serialized field, and we can just grab a reference to it in our awake. Player input controller equals get component player input controller. Stop. Input controller. There we go. Semicolon. Fantastic. Cool. And sweet, that makes this really simple. So one thing you'll also notice, like all of the classes that we have so far are super small. Like I don't think we've got, the longest class that we've got is probably this one at 43 lines of code. Oh no, 66 for our player pawn controller, but that's still like tiny. The rule is usually 200 is the max, so we're doing good. Ninja Man, welcome back. You haven't missed much, to be fair, I don't think. I'm not sure when you dipped out, but we have a player pawn now which can move. I'm going to take this and turn it into a prefab. So I'm going to go ahead and just make a folder for my prefabs here. Drag and drop that into there. And delete it from my scene. And then on our player main controller, we'll make this a prefab as well. But I'm going to go ahead and on here, we're going to add our player controller. Oh, I don't want it to require a component of player pawn controller. I want it to have player input controller. There we go. So the purpose of this class is to be like our parent controller for the player, because they might be able to control different things as the game is going on. So just for the time being, I'm going to have this component be a thing that exists in the world. On awake, we get our input, and then we spawn in a player pawn, spawn it like that, and set the input controller on our player pawn so that we can do all of our movement and stuff. And the thing that we'll be able to see as well is that this now keeps all of our inputs separate. There we go. So things are moving around. We've got our player controller working as expected. We can sprint, we can walk. And if I drag a new player pawn in here, we're not getting any errors, and we're still only moving the one. Everything is like behaving sensibly, which is exactly what we want. Fantastic. No reference exception. What? When did that get thrown? Clear all input callbacks. Oh, of course. Yeah. On disable, we want to make sure that we don't call this if our player input controller is null. So quick little null check in there as well. Fantastic. This is good. This is good. So I think the last thing that I want to add in like 10 minutes before I dip out and inevitably go chill and or sleep is the foundation for our interaction. So I'm going to make a new folder in my scripts folder called interaction system. And we're going to create a new script called iInteractable. Yeah, of course. So Ninja Man asks, how much money did I make with my first game? And the answer is about $130 odd in net revenue. That's after Steam cut, chargebacks, taxes. Currently, we've sold 63 copies. The game launched with, I think, 530 odd wish lists, which is a very small number by like what you should be aiming for if you're releasing a game on Steam. And I'll prefix this, by commercial standards, Tirelands is a massive flop. Like, it's not successful at all, but that wasn't really what I set out for anyway. That wasn't my goal. The goal was just that I wanted to go through the process of developing a game to completion and releasing it on Steam. So by the standards that I have, it's actually done much more than I expected it to, being at having made nearly $150 in effectively 2 weeks, launching with just over 500 wish lists. It's now up to just short of 700 wish lists, 7 returns, 5 positive reviews, no negative reviews, and still like a regular user base of about, I think, 7 active users a day off the top of my head, with the average playtime for all users, or median playtime, being about an hour and a half. So yeah, that's all the stats there. I'll probably do a video about it at some point, actually, because there's a lot of lessons that I learned from that process, and I think it would, probably be interesting and helpful. So if you do want to see a video on it, let me know. Leave a comment on the live stream or send me a message on Discord or whatever it may be, and I'll look to make it happen. Cool. So for the interaction, I'm going to use a system similar to how CodeMonkey set up in his tutorial. It's a very good interaction system, good code architecture. I'll make some slight changes because it's not like perfect in my opinion. There's places where it could be more optimized and have less code duplication, because again, we're trying to stick to good coding principles: solid, dry, kiss, all the rest of it. So for our iInteractable interface, we want to define a public void try interact. I think I want to call it try interact. No, I'm just going to call it interact. We don't want a try about it, because if it was going to be try, I'd want to return a boolean for if the interaction was successful or not, and I'm not worried about that yet. We may be in future, but for the time being, I'm going to leave it as standard. and we'll pass in a game object called interactor, which is the thing that's interacting. We'll also have a public string interact prompt. And eventually I'm going to switch this away from being a string because I don't want to do like E to interact with this. I instead want to have like a custom data type that will be an icon and a action, so that I can just pop it up as like a speech bubble above the character's head, because I want the art style for this game to be very, very slim and cutesy, you know, nice and simple. And this is going to be a get. Cool. Where do I live? I'm in the UK, which is, you know, I'm in quite a fortunate position. I have a very good day job that pays me very well, and also is very, like has very good work-life balance. When I finish for the day, I'm done for the day. Like unless it's been, oh god, camera, unless it's been agreed ahead of time that I need to be doing work outside of work hours, work is done and I can step away and not think about it. So I'm not like itching to get away from being in a day job right now. I also own the flat that I live in. Me and my girlfriend bought it together the like summer last year, which means that our what's the word? Our expenses aren't like small, they're relatively high, and we're like looking to renovate the kitchen as well. So there's like loads of stuff that is going to make life expensive. That means it's not quite so simple for me to just quit and go do this full time. That is the goal eventually, and I think I'm absolutely going to get there, especially with a lot of the other stuff that I've got going on in Shibadog Studios as like a company outside of, you know, these internal projects as I call them now, which are the games that we want to make. There's stuff that we're looking at doing like business to business basis, and on a more sort of contract basis as well. So definitely it'll happen one day, and definitely it's possible to do it. You just gotta, you know, make sure that you're planning out stuff. And yeah, if I can make it happen, I'll be super chuffed. I'll feel like I've succeeded in life completely at that point, and I can die happy. That's the dream. Cool. So we've got our interactable interface. Let's go ahead and create a new player component for player interaction component. And this is going to have a public void, or maybe we do make this a bool. Public bool. My brain just stopped. I'll keep it as a void. Trigger interaction. We'll also have a let's set our parameters first, shall we? Serialized field, private float, interaction radius. We'll also have a, come on brain, serialized field, private transform, interaction center. I think that's actually all we need for now. And I'll go ahead and just do a quick on draw gizmos selected. Gizmos dot color equals color dot, let's say red. And we'll do a gizmos dot draw wire sphere. Position is going to be our interaction center dot position, and the radius is going to be the interaction radius. Cool. So then for when we actually trigger the interaction, we're going to have a separate method, public I interactable, get closest interactable, or check for interactable. Let's call it check for interactable. Maybe we can have this be a bool, and instead we'll just out I interactable closest interactable, like so. So then the way this is going to work is we're going to say closest interactable equals null, because we have to set a value for this out. That's just the rules when you're using out, is like an out variable in a method. And then we can do a collider array interactables. Oh no, colliders in range equals physics dot overlap sphere, and we're going to do it at our interaction center dot transform dot position. We are going to do it with a interaction radius as the radius, and we're also, let's have a layer mask, serialized field private layer mask interaction layer. I mean, I don't need to do that, actually. I don't need to do that. That's like an extra step. So then we could do a for each var collider in colliders in range. And we'll say if collider is I interactable, oh no, we'll do this different. We'll do if collider dot try get component I interactable or out closest interactable. I think I can do that because it knows the type. Yeah, cool. And then I can return true. Nice and simple. Otherwise, we return false. Great. So just to go over how this is working, we say by default closest interactable is equal to null. Get all of the colliders that are within the range of our sphere, and then for each of those, if one of them has a component of type I interactable, which we then output into our closest interactable variable, we return true because we've got an interactable. Otherwise, we return false because we don't. Had a really good time, Ninja Man. Thank you. I appreciate that. I'm glad you enjoyed the stream. I'm looking to do lots more, so please stop by if you get the chance to in future. And yeah, hopefully I'll make millions one day, but we can dream. Cheers, man. So in the trigger interaction, and this is going to be the final thing that I do now because I'm getting up to time on how long I wanted to spend on stream. We are going to do if check for interactable out I interactable dot interact, and we'll pass in game object as the thing that's doing the interaction as well. Cool. So I mean, we probably want to test that this is working, so I'm going to just go ahead real quick and make like a placeholder interactable. C# script test interactable. We'll say this implements I interactable. Our interact prompt can be press space to interact. And again, we're gonna abstract all of this out eventually, but for the time being, I don't care. I don't want to mess around with it. Debug.log, and let's throw in a little one of these so that we can say interactor.name interacted with name, so that we know what's done the interaction and what it's interacted with. Nice, simple debug item. And let's go ahead and make a cube, which I will stick our test interactable script onto. And I'm going to make a few of these. So the one over in the bottom left here is going to be rock. And then let's duplicate rock and call it, I don't know, tree. And then on our player pawn, we want to go ahead and stick on our player interaction component. We'll go ahead and create an empty for our interaction point. Pull this forward, maybe like, whoop, not up, forwards for like half a unit. And we'll set our interaction radius, yeah, like 1.5, maybe 2. Feels good to me. And then the last thing that we need to do is make sure that we're adding a callback for this in our player controller. So we'll hop over back to player controller. We will have a private player input controller, and I'm in the wrong class. I need to be on the player pawn controller. There we go. And then when we set all of our input callbacks, we'll say player. Have I named it right? Oh, I'm a dingus. We want a player interaction controller component. Interaction controller dot player input controller dot on interact triggered dot add listener, and we are going to do interaction controller dot trigger interaction. And let's make sure that we are doing the good things here as well, clearing all our callbacks, remove the listener like so. And in awake, let's also make sure we are saying our interaction controller equals get component of type interaction controller. Nice. What do you mean it's been changed? The reload, I guess. Sweet. Let's test this out. So the one at the top over here, this one's called tree. Let's go walk up to tree, hit space, player pawn clone interacted with tree, fantastic. And the one down at the bottom, this is rock, interacted with rock, cool. And if we stand over here and press the space button, we are not doing anything. Great. That is a good start. You know, we've got interactions set up, we've got a moving controller, it can sprint, and everything is following good coding principles with solid principles intact and dry in place as well. So with that, I want to say a massive thank you to everybody who stopped by the stream today. It's nice to be back streaming after sorting out all of the release on Tirelands and everything. Like I say again, if you haven't already, Tirelands is available on Steam now. It's out for £2.50 or $3 if you're in the US, or whatever the equivalent exchange is in your currency. It would mean a lot if you picked up the game and let me know what you think. It's not going to be everyone's cup of tea, but you know, it's nice to get feedback on it and continue making improvements. So I will look to stream again very soon, and until then, cheers guys.